Hey students, I'm just going to walk you through lesson 2.8. This is what my other classes, Math 3, 4, and 5, went over together with me on Friday. It's quite a tricky lesson, so please really pay attention today and make sure you take really good notes in your small notebook. So let me just show you what we talked about for the warm-up. It was very similar to our paper folding task. And let's just go ahead and try to write a general rule for this table. And so what we notice is each time this is being multiplied by 3. Okay. And so in this case, the general rule is this is basically 3, and this is 3 times 3, and this is 3 times 3 times 3. And so what you can see is this is 3 to the 4th power, this is 3 to the 3rd power, this is 3 to the 2nd. And you might have come up with something like this when you were doing the paper folding, except you probably came up with it was 2 to the power of something. What our general rule will become is instead of writing 1, 2, 3, 4, we will write 3 to the power of x. So the general rule in this case would be y equals 3 to the power of x. All right. So for the first about 15 minutes or so while you're watching this video, I'm just going to go through something that's called exponential growth functions. And you are going to practice together by making a poster. Okay? Just remember that on Friday the 10th, so I'm going to be coming back. I'll see you guys on Wednesday. But on Friday the 10th, you will be having an investigation that you're going to look at, and that's a criterion B investigation. So if you have any questions about the lesson today or what you're learning right now, please make sure you ask me on Wednesday before we take our investigation together Friday. Okay, so our goal together right now is to be able to look at a table and write an exponential function based on that table. And then when we do the poster, we're going to take a real life situation and apply it. Okay, so let's do a couple examples. Go ahead and get out your small notebooks. If someone could just pause the video and write down lesson 2.8, exponential growth functions. So if you remember the paper folding task, you saw something like this happening, right? And again, what was happening is each time the y value was being multiplied by 2. Now, this is exponential. It's different than linear equations because linear equations, you don't have to write down the paper folding. Linear equations, what you learned last year, like taxi A and taxi B. Just trying to draw a little table here. Whoop. Linear equations are different. And in linear equations, when you look at the difference of the y values, you are just adding or subtracting something. So again, with linear equations, you always see adding and subtracting, but we will know that it's exponential when we're not just adding and subtracting, we're multiplying. Okay, so in the paper folding task, we figured out that it was y to the power of, or 2 to the power of x, y equals 2 to the power of x. Okay, so I'm going to show you an easy way to figure this out every time. It's kind of like a little trick. All right, so this one you can write down. This is example 1. So pause the video and write this down. What we're going to look at is you always, always, always need to look at the change in the y values. So if I see what's happening here, I notice that each time I'm multiplying by 2. Okay, and I know now that that's going to be exponential and not linear, because linear is always plus or minus. Exponential is multiplication or division. Okay. For those of you who were here last year, we're going to go back to that slide. For those of you who were here last year, you might recognize this. The parent function. And I think Mr. Addo called it mother function, but I like to call it parent function. Last year, you looked at the parent function of a linear equation of a line. And that parent function was y equals mx plus b, or plus c, if you remember that correctly, right? And this is when, if you go into a taxi, if you step in, that's the initial cost, and then this is going to be the amount that you're going to pay per kilometer or per mile. There's also a parent function for exponential equations, which is what we're looking at now. And the exponential parent function is y equals a times b to the power of x. And the way I like to say it is the a value is the now, and the b value is the change. Okay, and I'll show you how that works in a minute. So it's y equals the now times the change raised to the power of x. So pause it and take some notes. And let's look back at this, this example 1. So if I think about the parent function of an exponential, right? I know it's exponential because it's times 2 times 2 times 2. If I think about the parent function, the change is the times 2 times 2 times 2 part. So the change is always the b value, and in this case, the change is 2. We can figure out what the now is. We can figure out the a value by looking at when x equals 0. So the start point, the now, is actually 5. Okay, so my general rule for this table is 5 times 2 to the power of x. And I can go ahead and verify to see if that works. Remember, when you're doing a criterion B task, you have to make sure you verify. So let's also together write down a verification. I'm going to use the values of x equals 3 and y equals 40 to verify my general rule, to see if I got it right, to check it. So when you verify, you'll write down the original general rule. And then you're going to use substitution to, instead of writing y, you're going to write 40, because I'm using this value to check it. And I'm going to rewrite the other stuff from my general rule, raised to the power of x. And my x value in this case is 3. Okay, and then you'll show each step of the way solving it. So this is 5 times 2 to the power of 3 is 8. Oops. And then we've got, so 40 equals 40. And there's your verification. Okay, and when you're doing a criterion B investigation, you're always going to want to verify at least 3 times. That's a proper verification. Okay, so again, the A is the now, and we can find that by looking at when x equals 0. And the B is the change, and we can find that by looking at the first difference of the y values, so seeing how they're changing. All right, so what I'm going to do now, I'm going to do one more example. Let me just show you what it looks like. This example is exactly like the poster that you're going to do in just a second with a group. Okay. So watch me walk through it. I'm going to make a table. I'm going to make an equation or a general rule. That's the same thing. And then we're going to graph it. Here is our question. And again, you are going to do these 3 things with a small group that I've assigned to you, that the substitute will give to you in just a second.